We are going to find the volume that is common to these two cylinders. Each of them has a radius of 5 units and the axes are perpendicular to each other. So what we can do is this, that is, we can take the equation of one of the cylinders as this, of radius 5, okay, that being this one, and then the other one being y square plus z square equals 25. So these are the two cylinders we have. And in case you don't want to get into the equations of the cylinders, don't worry. We should be able to work with only one variable calculus in here. So what we have in here is this. That is, if you see this here, we have right here, this is the XY plane here, okay? And so that plane is, I'm sorry, I took too light a color here. So let me just change it. So this is the XY plane, okay? So when this happens, because you can see all this extra portion will all be removed. Okay, so what we will have is this: when we remove all these, that we shall have the sections parallel to the XY plane as being squares, okay, of course decreasing area, as I'm going to show you in the next figure. I brought these two pictures from Wikipedia, which is much better than mine for explanation purpose. So what you are doing is that you're going to take this part out. So this is the intersection part, and you can see this here. That is the sections that are parallel to the XY plane. They are squares, right? Okay. And since they are squares, we can just go ahead and measure one side and then compute the area of this square and multiply that with the element along z, which is delta z, and then add them up to get the volume. So let's just go ahead and finish the calculation. So now we shall do this, just calculate one side here in this picture. So let's look at that particular side. And in there, say we have the height of this is, say, z. All right. And you can see this here, that z varies from -5 to +5. And this equation is x squared plus z squared equals 25 of radius r. So this distance is x and this is 5. So that gives us what? X squared is square root of 25 minus, sorry, not a square root. Actually, let me just write x as a square root of 25 minus z square. Now, this being just half the length, the total length will be how much? The total length will be 2x, which is going to be 2 times the square root of 25 minus z square. So this length will be the same, that is 2 times the square root of 25 minus z square. So what we have is, so we have that basic element as a, as a just this square slab, and this length is delta z. So what this elementary volume will be, this is length, this is width, which are the same. So we will just go ahead and square it. So we get 2 times 25 minus z square square, and then multiply by the width. And then the integral will be from -5 to 5. So let's just go ahead and calculate that. So I'll just, find some space right here. Okay, so we can erase this. So all that we are doing now is that we are going to integrate from -5 to 5. This quantity is how much? 2 square is 4, and then we have 25 minus z square. When we square the square root, that sign will disappear, and then we got a dz. So we got 4, and then we have 25z minus z cubed over 3, and this ranges from -5 to 5, and just a little more erasing here. Okay, so what you will have then is 4 times, this will be 25 times, I'll have 5, then -5, so that will be 25 times 10, and then minus, we will have 5 cube minus 5 cube again, but so the two together will become 2 times 5 cube divided by how much? 3. Just make some more space here. Okay. And then you have this whole thing equal to, we have 4, and then we got 250 minus 5 cube times 2 is, that is also 250 over 3. So we will have 4 times 500 over 3, and that is, we can just say 16 times 125 over 3, cubic units. So that's what our answer will be here. Okay.